Good evening, everyone. This is June 2015, Unit 4 of IAL Chemistry. In the first question, what is the name of a compound below? So first, it's a geometrical isomer. Either it can be E or Z. Z means that the two heavy groups, the priority groups are on the same sides. But when we check here, iodine with methyl, so iodine is heavy group and methyl, so it should be E. So heavy groups are on the opposite sides. And when we count the number of carbon, if we start numbering from here, 1, 2, 3, 4. So second position we have a double bond, and third position we have iodine. If we count the other way around, 1, 2, 3, 4. So second position we have double bond, and second position we have iodine. So we always start the numbering from a nearest double bond or the functional group. So second position, first the isomer is E. Then second position we have iodine, so 2 iodo. There are 4 carbon atom, that's why it is but, and because the double bond between second and third, so it is 3. In question 2, which of the carbon atom marked with an asterisk is a chiral? To be a chiral carbon, it should bond with 4 different groups. So when 4 different groups are attached to carbon, that's a chiral carbon. When we check this one, 2 of the bonds are with the same oxygen, so this cannot be chiral. When we check this one, this will be 2 hydrogen attached, so it cannot be chiral. When we check this one, different groups are attached, so this will be chiral. And again for this carbon, 2 hydrogen will be there, so this cannot be chiral, so C is the right answer. Calculate the pH of an aqueous solution of hydrochloric acid of concentration 0.4 mole per dN3. So we have the formula pH is equals to minus log of hydrogen ion concentration, and HCl will dissociate into H plus and Cl minus. So concentration of, because for strong acid it's ionized completely, the concentration of acid is same as the concentration of hydrogen ion. In this case, it will dissociate, same number of hydrogen ion will be there. So when we substitute, take logarithm minus log of hydrogen ion concentration, so it will come out as a 0.4. Which of the following is most suitable carrier gas? The carrier gas should not react, it should be inert, unreactive. So oxygen cannot be used, can react, ammonia can react. Carbon dioxide is inert in nature, does not react often. Water vapor also can dissolve the substance, so the most suitable is carbon dioxide. What are the units for Kp? So Kp, the pressure of R raised to power 8 divided by pressure of P and the pressure of Q raised to power 3. When we substitute, this will be atm raised to power 8, this will be atm, and this will be atm cube. So when we solve, so we are left with atm 4, so C is the right answer. This question is about reversible reaction. N2O4 changes to NO2. A chemist investigated this reaction, started with 5 moles of N2O4 and allow the system to reach equilibrium. If 2 moles of NO2 formed, the amount of N2O4 at equilibrium. So N2O4 changes into NO2 In the beginning, this is 5, this will be 0. But at equilibrium, how many moles we have? 2. So how many moles of N2O4 will be there? The ratio is 1 is to 2. So this is, we have 2 moles, so this will be X cross multiply. So we'll get 1 moles of N2O4 is used. So how many are left? So 5 minus 1, that is equals to 4. So D is the right answer. Under different conditions, 25% of moles of gas present at equilibrium is N2O4. If the total pressure of a system is 3 atm, numerical value of equilibrium constant Kp. So if 25% is N2O4, so remaining, so and remaining 75% will be NO2. So the total pressure is 3. So 25% of 3 and 75% of 3. So 25% of 3, that will be equal to 0.75, and 75% of 3, that is 2.25. So 2.25 is the pressure, partial pressure of NO2, and N2O4 exert a partial pressure of 0.75. So when we write the expression for Kp, pressure of NO2 square divided by pressure of N2O4. So pressure of NO2, that is 2.25 square, divided by pressure of N2O4, that is 0.75. When we solve this, it will come out as 6.75. So B is the right answer. For question 7, if the pressure of the system is decreased at a constant temperature, which of the following statement is correct? So when we check the number of moles, 2 moles in a reactant side and 1 mole in a product side. So decrease in pressure shift the equilibrium towards side where number of moles are more. So equilibrium will shift toward left hand side. So these are the points left hand side. But what happened to value of the Kp? The value of the Kp is affected by temperature, not affected by the shifting of equilibrium. So the Kp will remain same. That's why B is the right answer. The table shows some data about the metal ion and non-metal ion and their compounds. What is a standard enthalpy change in the for the following? So here, ions in the gaseous state convert into ions in aqueous state. We call that as hydration energy. So how many moles strontium? 1 mole of hydration energy for 1 mole, it is minus 1443. Plus fluorine 2 moles, minus 483. So when we solve, it will come out minus 2409. So D is the right answer. What is the standard enthalpy change of solution in kilojoule per mole for rubidium chloride? So enthalpy change per mole for rubidium chloride, the formula for enthalpy change of solution is equals to hydration minus lattice. So hydration energy, rubidium chloride, so hydration energy minus 297, that's for rubidium, plus minus 340 is for chlorine. Minus the lattice energy minus 685, that is a lattice energy. So when we solve hydration minus lattice energy, it will come out as plus 48 kilojoule per mole. Which of these solvent would not warm by microwave radiation? Microwave radiation, it affects the polar bonds. So when we check H2O, because OH bond is there, that will be polar, so it will be affected. Tetramethylsilane, when we check silicon bonded with methyl group, so bonds are non-polar, molecule is also non-polar, so it will not be affected by microwave. Hexane, cyclohexanol will have OH, so it is also affected. And trichloromethane, because the bond is there between carbon and chlorine, that is a polar bond, which result in absorption of this microwave. So B is the right answer. In question 10, some chemical tests are described below. Warm with Felling or Benedict solution is used for aldehyde. Warm with iodine dissolve in alkali, that is if methyl group is there next to carbonyl. Add sodium carbonate solution, that's to identify acid. And add 2,4-dinitrophenyl hydrogen, that is for any carbonyl, aldehyde or ketone. Which test would result in effervescence? So because it contains carboxylic group, and if we add sodium carbonate, it will give carbon dioxide, fizz, bubbles, effervescence, and the gas which is given off will turn lime water milky. Which test could be used to distinguish between aldehyde and ketone? So Felling or Benedict, because aldehyde will give a positive result with Felling or Benedict solution, but ketone does not react. So A is the right answer. Which test result in orange yellow precipitate? So triiodomethane reaction, that is adding warm with iodine dissolve in alkali. So this will give a yellow. Which result orange yellow precipitate. So orange yellow precipitate, that is 2,4-dinitrophenyl hydrogen. If it was iodine dissolve, and it will give a yellow precipitate but not orange yellow, because they mention here orange yellow, that's why D will be the right answer. Question 11, consider 4 compounds. Which of these compounds form most acidic solution when equimolar each compound separately dissolve in water? So when we dissolve, this will C double bond aster is there, so it does not affect the pH. This will have pH less than 7. This will also make pH less than 7, but when it react with water, it will give HCl, and HCl is more acidic than isethanoic acid. That's why D is the right answer. Which of the compound has a peak at 3348 in infrared? Use a data booklet. So when we use a data booklet, 3348, that range is in amide. So 3500 is 2140, so 3348 is in this range, and that's for amide. So which one of them is amide? C is amide, so that's why C is the right answer. Most likely to be used in a fruit flavor, so it should be an aster, so that's why A is the right answer. Question 12, this question is about nucleophilic substitution reaction of hydrogen cyanide to butanol. Which of the following reagent will lower the concentration of nucleophile CN? So if we add acid, because ethanoic acid is a weak acid, so it will not increase the amount of proton much. But when we add hydrochloric acid, it increases the amount of H, so it will shift the equilibrium towards left hand side. So As equilibrium shifted toward left hand side, amount of nucleophile will decrease. That's why B is the right answer. Then the intermediate which is formed during this reaction, so when Cl will form a bond, O will take the intermediate X for this reaction. So when oxygen will take, this will turn into single bond, and this will have a bond. Carbon and Cn will have a bond with each other. So which one it matches with? It matches with option A. So A is the right answer. And then which statement about this mixture of organic product form is not correct? So when we check contain product that is with one more carbon than the ketone, that's true. Rotate the plane polarized light. We have to check the product which is formed should have a chiral carbon. It is having a chiral carbon, but what happened? Because it's a trigonal planar, so Cn can attack from any side, so it result in a formation of a racemic mixture. So as the racemic mixture is formed, it cannot rotate the plane polarized light. Contain product with nitrile functional group, that's true. Contain a product which is chiral carbon, that's also true, because all the bonds which carbon form are with different elements or atoms or group of atoms. So B is the right answer because it will form a racemic mixture which does not rotate the plane polarized light. So this was June 2015, Unit 4 of IAL Chemistry.